Okay, we're going to go ahead and do 11.3 in this video. What we did last time was we did arithmetic sequences where we're adding or subtracting by a common difference. And in geometric sequence, it's when you're multiplying or dividing by a specific number. So notice here you have a 2 and a 4 for arithmetic, and notice in geometric you also have 2 and 4. So you really can't tell if you cover this part up, or if you really can't tell just by using two numbers. You have to go out to three numbers before you can tell the difference. So when you're doing these and you're trying to determine if it's a geometric or arithmetic, have at least three terms. Okay. For geometric, basically what you're doing is you're given a certain number, you're multiplying it by another number. The next time you're multiplying it by that same number again. That's why your ratio here is squared. We can go ahead and write this out as an nth term by giving this formula. We're starting with this one, and then it's n minus 1. This is term 2, but r is to the first, so that's why we subtract 1. This is the third term, but we're using r2, so it's always going to be n minus 1. All right, let's go ahead and determine if these are geometric, or if they are geometric, and if so, what's the common ratio. So the way you should start these actually is start by the second term, or pick any one of these terms. I'm just going to start with 6, and I'm always going to divide it by the previous term. So the term before that is 2, and here we get 3. Okay, we're going to go ahead and pick out another one. I'm going to go ahead and pick out the 18, divide that by 6, and you also get 3. As long as you get the same number, yes, this is going to be a geometric. Let's go ahead and do that over here. 6 divided by 2, that's 3. And let's do the 10 divided by 6. That's not 3. This is going to be 5 thirds. This is not a geometric sequence. Okay, so this is, and this is not. Okay, all right, let's go on to the next one. It says here, write the first 4 terms of the sequence. We're starting with A1 as being -2, and then R as being 4. So all we're going to do is do A1. That never changes. We're going to keep that the same. Now we're going to do A2. Okay, A2, using your formula, use the first term, which is -2, and then we're going to multiply it by R. R is going to be 4. Okay, so just multiply it. -8. Okay, so A3 is going to be -2, 4. Remember I said here use 1 minus. Third term, this is going to be squared. Use your calculator. You should get -32. A to the 4th, A1, 4, which is R, to the 3rd power. This will be -128. Okay, just use your calculator to do those calculations. We're going to go ahead and go on. Okay, all right, here it says write the formula for the nth term of the geometric sequence. So here we need to know what our ratio is. We know that this one is going to be our A1, but our ratio we don't know. So I'm going to go ahead and do R is equal to take the previous term, one of the terms, and divide it by the previous. Okay, let's see if this works. Okay, so if I put it in here, let's do it with the 4. I can say 4 times 4 is 16. 1 times 5 is 5. So this actually works. Let's go ahead and put it in the actual formula it's asking. So it's saying AN, okay, A1, which is 5, our ratio, which is 4/5, and then it will be n minus 1. Remember, always subtract 1 from that one. So here we go. There's our formula. All right, next page. All right, number 5. Find the 6th term of the geometric sequence where A1 and we have A2. Okay, so it's actually telling us there's a geometric sequence. Let's go ahead and find out what our ratio is. So we know A1 is equal to 10, and we know that R will be equal to the second term divided by the first term, so 12 divided by 10, Go ahead and simplify this to 6/5. Okay. Now we're going to go ahead and write the general form. So AN is equal to 10 6/5 n minus 1. Just use your formula. Now we're going to go ahead and find n. Let that be equal to 6 because that's what it's asking for. So a to the 6 is equal to 10 6 to the 5th raised to the 5th power. Okay. Put this in your calculator, and I'm going to show you how to do that. I'll go ahead and show you how to do that here. We're going to start with the 10, put the parentheses, 6 divided by 5, close it, and raise it to the 5th power. So that little caret and 5. Okay. Always make sure you change this back to a fraction. I believe that's the way Alex is going to want it as well. And there you go. You get 1,555,2 over 625. That's going to be your correct answer. Number 6 says find R and A1 and an expression for the nth term of the geometric series. So here it's telling us this is geometric where we have a of 4 and a of 7, but it says a of 7. So let's go ahead and do this one. This is going to be slightly different, but it shouldn't be too complicated. Okay, so let's go ahead and start with the first one. I know, and there's going to be different ways to solve this, but I think this is the easiest one. I'm going to start with the general term. A of n is equal to a of 1, r, n minus 1. That's our general equation. Now I know 4 and I know 7. So I'm going to go ahead and do this twice. I'm going to go ahead and do it for a of 4 is equal to a of 1, r, 3. Okay? All I did was plug in the 4 here and then subtract 1. If this is true, I can substitute what my a of 4 is equal to, and I'm going to be left with two unknowns. I'm going to be left with an unknown a of 1, I don't know what that is, and my ratio. So I'm going to go ahead and plug in my negative 240 is equal to a of 1 r to the 3rd. Okay? Now I'm going to go ahead and do this again using a of 7. So a of 7 is equal to a of 1, we still don't know what that is, r, we still don't know what that is, but we do know that the exponent is going to be 6. Substitute the number of a of 7 into here, I'm going to use the 1920, is equal to a of 1 r to the 6. Now here's the interesting part. What we can do is we can actually solve for a of 1 or we can solve for r. Now, I wouldn't recommend solving for r in this case because you have those exponents. So what we can do is go ahead and put everything in terms of a of 1. So I'm going to go ahead and do that over here by dividing by r of 3. And I'm going to do that over here too by dividing by r to the 6. Now I have two a of 1s. I can actually set those equal to each other. And over here, I'm using what a of 1 is equal to this side. Negative 240 divided by r to the 3rd. Over here, I'm using what a of 1 is equal to on this side, which is 1920 r to the 6. Okay? Now what I can do is go ahead and solve for r. I'm going to multiply both sides by r to the 6. What happens here is this will cancel out. And I'm going to actually rewrite it over here, but you will see that over here you get r to the 6 over r to the 3rd. Okay? Here, I'm going to go ahead and divide this side of the equation by negative 240. What will happen is these will cancel out. Okay? So now what I'm going to do is simplify this side of the equation. I'm going to say 920 divided by the 240. And here I'm going to get 8. So I'm going to say this is equal to negative 8 because the negative is still here and 240 goes into 928 times. Simplify this side of the equation. I'm going to get r to the 3rd. 3 of these cancel out with 3 of those is equal to negative 8. And then I'm going to do the cubed root. So I'm going to do 3 second caret, that gets me cube root of negative 8. And press enter, and then you see that r is going to be equal to negative 2. Okay, So now what we have is we have r. We do not know what a of 1 is, but we do have two equations here where we can solve for it. I'm going to use this equation because I'd rather cube it instead of raising r to the 6th. So I can say a of 1 is equal to negative 240 divided by r cubed, which is negative 240 divided by r cubed is negative 8. Negatives cancel each other out, and then I'm going to say that 240 divided by 8 is going to be 30. So a of 1 will be equal to 30. Okay. The last thing it says here is we found r, we found a of 1. Now express it in the nth term. So we're going to just use the original equation that I have here, and I'm going to say a of n equals 30, because that's what a of 1 is, r, which is negative 2, n minus 1. Okay, and that's it. You're done. Don't try and multiply these two together. Those cannot be multiplied together. Okay, so there's all my equation right there. All right, next part. Okay, just like what we did before, we actually found summation. So when we're doing the summation of a geometric equation, we do not need to find the very last term. All we have to do is know this equation, and that's going to be given to you on your formula sheet. The only thing you need to know here is r cannot be 1, which is obvious because here, if this is 1, you get 0 in the denominator. But let's go ahead and solve some of these. So if I'm starting with number 7, if I'm looking at this equation here, you can see that it is essentially in the same format as your formula. So I'm going to go ahead and bring it down here. Notice that you have a of 1, here's my a of 1, r, here's my r, n minus 1, this is I minus 1, which is completely fine. So this format matches this format. So what we can really easily do is just say, well, a of 1 is equal to 3, and r is equal to negative 1/3. N is going to be equal to 8, because you start at 1, you go to 8. Okay, so now I can go ahead and use this formula up here to solve for that. So I'm going to say s of 8 is equal to 3, 1 minus, careful here, this negative goes with the formula, this negative is attached to r. So I'm going to do negative 1/3 raised to the nth power, which is 8, close it, divide by 1 minus, and again, negative 1/3. In order to put this in the calculator, which you can do, you just need to be careful on how you do it. Remember, the entire numerator needs to have its own parentheses, and so does the denominator. I'm writing brackets here, but you can just use it as parentheses when you put it in the calculator. So let's go ahead and do that. 3, 1 minus negative. Make sure to use the little negative down here when it's inside the parentheses. 1/3 raised to the 8th, and then you have two parentheses after that. 1, 2, divided by parentheses 1 minus negative 1/3. Close it and close it. Enter. Second PRB, you're going to change it to an improper fraction. So here you're going to have this is equal to 640 divided by 729, and that is actually the correct answer. Okay, when you add these up together, that's what you get. Number 8. Okay, so a of 1 is the first term, which is your 3. A finite geometric series. So r is going to be 2, multiply by 2, multiply by 2. So r is equal to 2. Okay, and n. Okay, so here in this case, we don't know what n is. So we're going to go ahead and find that first. Let's go ahead and write out the formula for that. A of n is equal to a of 1 r n minus 1. Okay, there's our formula. Let's go ahead and put in we'll put in the terms. I know that the last term is this, so that's my nth term, so I'm going to use 1536 is equal to a of 1 I know is 3, r I know is 2, and then n minus 1, this is the part that I don't know. So what I'm going to do first is divide by 3. Do not try and multiply these two together. You can't do that. Do this part first. We're going to do 1536 and divide that by 3. I get 512 is equal to 2n minus 1. Okay, so if you remember your exponential rules, can we change this to a base of 2? This is one way to do it. Well, yes. Remember, if I want to change my base to a 2, I can use exponent rules. We're going to use the calculator for this. I'm going to go back and say logs, because it's the same thing as exponential, and we're going to use logs. So I'm going to do log of 512, and I want to change it to a base of 2, so I'm using log 2, close parentheses. That's 9. That means 2 to the 9th is equal to 512. Well, let's just verify that. 2 raised to the 9th power, 512. There you go. So here's going to be 2n minus 1. Now, remember what we can do is set when our bases are the same, we set our exponents together. So 9 is equal to n minus 1. Therefore, n has to be equal to 10. So now that we have that, we can go ahead and go back and find the summation. Because remember, what you're looking for is the sum here. So use the formula. S of n is equal to a of 1 minus r, n over 1 minus r, is I use this formula. So a of 1, remember the first one is for arithmetic, second one is for geometric. So a of 1 minus r raised to the n, 1 minus r. So now that we have the equation, let's just go ahead and fill in our values, because now we have all of our values. So S of 10 is equal to 3, 1 minus 2 to the 10th divided by 1 minus 2. Plug that into the calculator. Again, remember the numerator has to be in parentheses as well as the denominator. So I'm going to go ahead and do that for you here. Parentheses 3 times 1 minus 2 raised to the 10th, close, close, divided by 1 minus 2. Press enter. So S of 10 will equal to 3,069. This is going to be your answer. Okay. All right. The last one that we're doing, infinite geometric series. In other words, we don't have an nth term. We're going on to infinity. Hey, how do you go from the number 1 to the number 2 if all you're doing is eventually adding 9,9,9,9,9 at the end of your decimal? You never really can jump to 2. Well, this is how we go from one number to an x, is when we add up the geometric sequences, we can actually find out that it does jump to 2 eventually. So let's go ahead and we'll look at this equation here. It's on your formula sheet separately. So even though that these are geometric, this is the only one for infinite geometric series. So when you go to infinity, which is the one that you're going to be using here. If you see the infinity signs or a dot, 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 that means you're using the infinite geometric sequence. Okay, let's go ahead and do this one. It's in the same term. Here's your a of 1, here's your r, here's an n minus 1, or in this case, the k minus 1. So I'm going to go ahead and list out what all our values are. A of 1 is equal to -6, r is equal to -3/5. Okay, and then n is going to be infinity, but we don't need to use an n when we're doing this equation. So let's just go ahead and put it in here. S is equal to a of 1, -6, divided by 1 minus -3/5. Okay, again, use the parentheses in the denominator. Numerator in this case doesn't need it because it's a single number calculator. Okay, -6 divided by 1 minus negative 3/5. Okay, change it back into a fraction, and you get negative 15/4, and that's going to be the summation. Okay, if this is added continuously. In this particular case, r cannot be greater than 1. If r is greater or equal to 1, then the sum is not going to exist. And if you think about it this way, if I have, let's say, an r of 2, and I'm starting with a number, I'm going to go ahead and show you on here. If I start with 2, let's say a of 1 is equal to 2, and r is equal to 2. Let's see what happens if we're going to infinity. We start with 2, then it's 4, then it's 8, then it's 16. What's happening to my numbers? Well, they're actually getting larger and larger and larger. I can't add numbers that are actually doubling, so the sum is never going to exist. It's just going to go straight to infinity. Okay, so when you're doing these infinite sequence, r has to be less than 1. And what I mean by that is just a fraction. It can be a negative sign, and that's okay. It just can't be a number that's equal to 1 or greater. Okay, so let's go ahead and look at number 10. For number 10, we're going to go ahead and say a of 1 is equal to 4, r, negative 6 divided by 4. Well, you can see here, this is going to be negative 3/2. This part of the fraction is an improper fraction because you got a 3 at the top and a 2, which means if I took the absolute value of this, it's going to be equal to or greater than 1. So this one, the sum, does not exist. Okay? All right. That's it for 11.3. We have one section left. If you have any questions or need additional information, please let me know.